This is Geometry, section 9.5, Dilations. So this last section that we're going to do in this chapter is different than all the other sections because the biggest thing about a dilation to remember is that it is not an isometry like the other three that we've talked about are. Translations, rotations, and reflections are isometries because they change the shape, or they move the shape, but they don't change the shape. A dilation is going to change the size of a shape, so that's why it's not an isometry. It changes size. Okay, so a dilation, if you think about dilation, if you've ever heard of dilating someone's pupils, that just means to make their pupils really big. So your pupil is a small circle, and when you dilate it, it makes it bigger. So that's the idea of a dilation. A dilation could make something smaller as well, or a bigger version of itself. So either a smaller or bigger version of itself. It stays the same shape, but it just becomes bigger or smaller. We need a center point, just like we do for a rotation. So we need a center point. We usually call the center C, C for center. We also need a scale factor. We've talked about scale factor when we talked about similar triangles, and we'll talk about that again. It's a similar concept. So we need a scale factor, or how much bigger or smaller something becomes. So the scale factor is usually a number that we call k. So when k is greater than 1, the dilation means that the shape is going to get bigger. When it's a number bigger than 1, it gets bigger. We call that an enlargement. And when it's between 0 and 1, so k is less than 1, but k is greater than 0, because it can't be negative. It can be negative, but we're not really going to deal with that. So when it's between 0 and 1, it's called a reduction. It gets smaller. Okay, so use a ruler to draw each dilation, just like with the rotations. This is hard to do on a video. We're going to use rulers in class to do this. So to draw a dilation with a given point C and scale factor K, this scale factor is not filled in. This should be a 2. So scale factor of 2 means that it's going to get twice as big. It's also going to get twice as far from the center point. So to do this with a ruler, we're going to draw a straight line from C to each of these 3 points. We're actually going to extend the line past it as well. So through the point and extended, through the point and extended. And then we're going to measure the distance between this point and this point, and then we're going to go twice as far. So we're going to measure the distance from here to here, and then we're going to go twice as far. That'll probably be a little bit further. So about right there. This one, we're going to measure the distance from here to here, and then we're going to go twice as far along that line. Here to here, and then we're going to go twice as far along that line. So this dilation, our final result, our final image would be this. If this was our pre-image, this is our image right here. It's twice as big and twice as far away from the center. If our scale factor is like this, it's 1/2, then when we draw these lines out, what we're going to do is instead of going twice as far from the center, we're going to go half as close to the center. So if this point, this distance from C all the way to this point goes from here to here, I'm going to go half as far to find my image point. From here to here, I'm going to go half as far. Or really, I'm just finding the midpoint of these segments. So my image would be this. It's half as far away from the center, and it's half as big. So if a dilation is centered at the origin, much like with rotations, we did rotations around the origin. So if it's centered at the origin of the xy plane, all we need to do with our scale factor is just take the coordinates, so each coordinate, the x and the y, and multiply them by the scale factor to find the image. So if we look at these points, this point right here is 2, 8. This point right here is 6, 4. This point right here is -4, -2. So if I take all of those points, all of those numbers, and multiply them by 1.5, then I'll get my image points. So 2 times 1.5 is going to give me 3, and 8 times 1.5 is going to give me 12. So this point is going to go to 3, 12. 6 times 1.5 is going to be 9, and 4 times 1.5 is going to be 6. So this is going to turn into 9, 6. -4 times 1.5 would be -6, and -2 times 1.5 would be -3. So we would graph all of those points. So this shape, this bigger shape is 1.5 times bigger than this first shape that we started with, and it's 1.5 times further away, or all of the points are further away from the origin. This one gives us a scale factor of 1/2, so we know that this shape is going to be smaller and it's going to be closer to our center, which is the origin. So now I go through and I look at all these coordinates. So these coordinates are 2, 10. This is 8, 10. This is 8, 6. This is 4, 6. And this is 2, 8. So if I take all of these now and multiply them by 1/2, then I get the coordinates of my image shape. So 2 times 1/2 is 1, 10 times 1/2 is 5. So that point turns into 1, 5. This point, 8, 10, would turn into 4, 5. 4, 5. 8, 6 would turn into 4, 3. I'm just making everything half as big. 4, 3. 4, 6 would turn into 2, 3. And 2, 8 would turn into 1, 4. If I connect all my dots with straight lines, just like this shape, it's half as big and it's half as far away from our center, the origin. All right, find the image of the coordinates. A is 212 and B is 16, -8 after a dilation centered around the origin. So it gives us a scale factor of 1/4. So all I do is take all of those coordinates and multiply them by 1/4. Multiplying by 1/4 is the same thing as dividing by 4. So 2 divided by 4 can just simplify to 1/2. So A prime would turn into 1/2, and 12 divided by 4 is 3. 16 divided by 4 is 4. -8 divided by 4 is -2. This is just a mistake. That shouldn't be here. So next example, with a scale factor of 2, followed by a translation of 7, -5. So we'll come back to this in a second. That's going back to the first section of the chapter. So let's do a scale factor of 2 first. So if we take these points, we're using the same points, A and B. So we're multiplying everything by 2. So 2 turns into 4, 12 turns into 24, 16 turns into 32, -8 turns into -16. Now we need to take these points and translate them. So we remember from translations, this tells us what to change the x-coordinate by. The second number tells us what to change the y-coordinate by. So for both the x-coordinates, 4 and 32, I'm going to add 7. And then for both the y-coordinates, I'm going to subtract 5. So 4 plus 7 turns into 11. 24 minus 5 turns into 19. 32 plus 7 turns into 39. -16 minus 5 turns into -21. All right, so figuring out how to relate scale factor based on the size of shapes. So figuring out the scale factor if you know both the shapes. Before we knew the scale factor, we had to figure out the image from the pre-image. Now we have the image and the pre-image, and we have to figure out the scale factor. So scale factor K is going to equal the distance between the center point and an image point over the distance between the center point and a pre-image point. So we're going to write that out in words over here. So distance from center to image, and then the distance from center to pre-image. And it has to be a corresponding point. So it has to be like A prime and A, or P prime and P, or B prime and B. It can't be A prime and B, or P prime and C. It has to be a matching point. So what we mean by that is, if we look at this bigger shape, the one that's further away, is our image, because that one has the prime on it. So if I look at the distance between the center and a point on the image, it gives it to me right here. It's 15. So that number goes on top to figure out the scale factor. The second point is going to be the distance between the center and the corresponding point on the pre-image. So these 2 points correspond to each other, so I can use those 2 distances because they correspond with each other. This point corresponds to this point. So 15 goes on the top because it's always centered to the image and then to the pre-image. So it's the opposite of what you would think. You start with the ending shape, that one goes on top, and then the beginning shape, that number goes on the bottom. So 15 over 10 reduces to 3 over 2, which is the same thing as 1.5, which makes sense because this number is bigger than 1, and this is definitely an enlargement. The shape is getting bigger compared to this one. So that would be our scale factor, 1.5 or 3/2. For this one, this is definitely a reduction because this shape is turning into this shape. It's smaller and it's closer to our center. So we know that this value should be less than 1, whatever we get. So if we get a number bigger than 1, we know we did it wrong. So we start with the distance from the center to a point on the image, which would be right here, 8. So that's what we start with. And then the distance from the center to the corresponding point on the pre-image. So that would be this point right here. If we went to this point, then we have to go to this point. It gives us the distance between the image and the pre-image, but we want from the center all the way to this point. So we have to add these two numbers together and get 18. So 8 over 18 gives us 4/9. That's what it reduces to. So this would be our scale factor. All right, last example, it says the graph at the right is a dilation about the origin. So it only gives us A prime. It doesn't give us B prime and C prime. We're going to have to find those. So first of all, is it an enlargement or a reduction? Well, it's definitely a reduction because this A prime is closer to the origin than A is. So it's definitely a reduction. It's getting smaller. Scale factor. So let's figure out the coordinates. Coordinates of A prime are 2 and 3. Coordinates of A are, whoops, this is 3, 6, not 4, 6. So 2 and then 3, 6. Okay, so if we compare, remember we're going to always put the distance from the center to the image on the top, and we know it's going to get smaller. So the scale factor is going to be a number less than 1. So the 2, we could compare the x coordinates and the y coordinates. 2 and 3 would go together, and then 3 and, whoops, this y coordinate is a 4. This should be a 4. Sorry about that. So this is 2, 4, sorry, and then 3, 6. So the 2 and the 3 could compare to each other, and the 4 and the 6 could compare to each other. We're going to use the image number on the top. So this was a 2, this was a 4, and then the other number on the bottom, or the pre-image on the bottom. So compares to this coordinate of 3, 4 compares to this coordinate of 6. These two fractions are really equal to each other because 4, 6 reduces to 2/3. So all you do is take the coordinate, just like we did when we had the scale factor and we had to find the image, we multiplied the coordinates by that scale factor. Now we're dividing the coordinates of the image by the coordinates of the pre-image. So the scale factor would be 2/3. It's 2/3 as large. And then graph the other 2 points. So we take these coordinates, whatever these are. So B is at 6, 9, and C is at 12, 3. So we take all those coordinates and multiply them by 2/3. So 6 times 2/3, 6 times 2 is 12, divided by 3 is 4. 9 times 2/3, 9 times 2 is 18, divided by 3 is 6. And then same thing for 12 and 3. So 12 times 2/3, 3 times 2/3. 12 times 2 is 24, divided by 3 is 8. 3 times 2 is 6, divided by 3 is 2. So there we go. Once we know our scale factor, we just take these coordinates, multiply them by the scale factor, and then figure out the coordinates. If we graph those, so B prime is 4, 6. B prime, and then C prime is 8, 2. We get a triangle that looks the same, it's just smaller and it's closer to our center.